Alright, let's take a look at the worksheet for 5.3, solving trigonometric equations. So first section, the introduction. To solve a trig equation, we need to use standard algebraic techniques such as collecting like terms and factoring. So basically what we're going to be doing here is solving just like we would a normal algebra problem, trying to get x by itself, but in this case, our goal is not just to get x by itself, but to get the trig equation by itself. So get cosine x by itself, or get sine x by itself, so that we can solve. And then once we do that, we're going to have one specific solution, and then we're going to have multiples of whatever solution we get. So it says here the equation of secant x equals 2 has an infinite number of solutions because the secant function has a period of 2 pi, which means every 2 pi, every full circle, we repeat. So any angles coterminal with the equation solution will also be solutions. So let's say we solve this secant x, and we're just going to take a quick peek at what we're doing here. Remember that secant is hypotenuse over the adjacent. So that's 2 over 1. So we have a spot here. This is the same as cosine x equals 1/2. And so if we looked on our unit circle and said, all right, where is the x value equal to 1/2? Remember, cosine is the x value. If we looked on the unit circle and said, where is the x value equal to 1/2? Well, we would find 60 degrees. But we would also add 360 to that and get 420 degrees. And we could add 360 to that again and end up with 780 degrees. So what we're typically going to write is we're going to say x equals 60 degrees, if we're in degrees, plus 2 pi, a full circle, n, meaning we can add 1 circle, or we can add 2 circles, or 3 circles, or 4 circles, as many as we want. Alright, so let's take a look at example 1. The solution is there. We're going to get to that in a second, but let's fill in the blanks here for our tip. To solve an equation in which 2 or more trig functions occur, collect all the terms on one side and try to separate by factoring or using appropriate identities. In this case, we have cosine squared, which is why we're saying there's 2 or more on one side. What we're going to do here is get the cosine squared by itself. So we're going to add the 1. We'll get 2 cosine squared x equals 1. Cosine squared x equals 1/2. And if we take the square root of that, cosine x will equal the square root of 1/2, which is the square root of 1 over the square root of 2. Can't have the square root on the bottom. We'll move it to the top. Root 2 over 2 is our answer. Positive or negative, because it was starting from the squared. When we took the square root, remember square roots have pluses and minuses as their answers. So anywhere that cosine is either positive or negative root 2 over 2, we're going to have our answer. And if we look at our unit circle, 45 degrees, or pi over 4, we get root 2 over 2 for the x value. So the cosine will be there at pi over 4. So remember, we're going to say pi over 4 plus 2 pi n, which is what this is saying here. Now, why is it pi n and not 2 pi n? Well, notice in quadrant 3, there's another root 2 over 2 solution. So we get the answer at 3 pi over 4, or I'm sorry, this is 5 pi over 4 as well. So it's not even a full circle necessary to repeat the answer. It's a half circle, and we're going to repeat our answer. So we can just say every half circle will repeat our answer. All right, that's for the positive answer. Let's take a look at where we find negative root 2 over 2 in the x value. And we find that at 3 pi over 4, as well as down here at 7 pi over 4. So now we have our second answer, 3 pi over 4 plus pi n. So notice that we have 2 distinct answers because we had a squared problem, so we need to have 2 solutions. All right, let's move on. All right, an example of a trig equation of quadratic type. We're going to have a squared and then a x to the first power and then an x to the 0 power. So anything you want as an example, but here's an example. Cosine squared x plus 4 cosine x plus 4. And to solve this, we would factor it. If we can't factor, remember we can always use the quadratic formula. All right, so let's solve an example problem here. This is going to be our answer, 3 pi over 4 plus n pi, or pi n. This procedure can introduce extraneous solutions, so any solutions must be checked in the original to see if they are valid or extraneous. So, because we're doing the square root, we're going to come up with positives and negatives, but we need to go back in and check to make sure that those positive and negative answers are allowed once we're done. Let's see how we do this problem. I think it might be helpful to, at the very beginning, say tan x and use a substitution. We're just going to use a placeholder. Call it u. Tan x equals u. So instead of tan squared x, I'm going to write u squared plus 2u. And we can bring the 1 over to the other side and say plus 1 equals 0. And so we can factor that. This is u plus 1 times u plus 1, or u plus 1 squared. And so u equals negative 1. But remember, it's not really u we're solving for here. It's the tan x equals negative 1. All right, so we need to go to our unit circle and find a place where the tangent is negative 1. And we have our sheet from our warm-up before of values for negative 1. And it turns out to be here and here at 45 degrees. The reference angle is 45 in quadrants 2 and 4. So this is 135 degrees, otherwise known as 3 pi over 4. And notice that we're going to spin around not a full circle to get back here, but just a half circle to get to our second answer. So we're going to have 3 pi over 4 plus pi n, not 2 pi n. All right, if we went back in and checked this, plug this into your calculator and make sure that it does come out okay, and it will. So we're going to be all right, and that'll be our solution. All right, number 3 here, give an example of a trig function of multiple angles. All right, so something like instead of tan x, tan of 4x, or in our example here, sine of 4x. So we're going to go ahead and solve this just like we normally would, and we'll deal with the 4 as our very last step. So where does sine equal root 2 over 2? That happens at 45 degrees, otherwise known as pi over 4. And that also happens here at 3 pi over 4. All right, so 2 distinct answers, and then we're going to have to spin a full circle to get back to each answer. It's not a half circle, so we have pi over 4 plus 2 pi n, and we also have 3 pi over 4 plus 2 pi n, multiples of your whole circle. All right, and that, however, does not equal x. That equals 4x. So 4x equals both of these things. So what are we going to do with our final answer? We're going to divide everything we see by 4 to get x by itself. Okay, so our final answer here is x equals pi over, what's this fraction going to be? Is it pi or is it pi over 16? Make sure that you get pi over 16 as your correct answer. And we're going to also divide the 2 by 4 and get pi over 2n. And it also is going to have x equals 3 pi over 16 plus pi over 2 as our final answer there. All right, moving right along, last example here. Let's talk about answers that don't show up on our unit circle. So we have this, we're going to factor it. I'm going to use my placeholder again, u for tan x, so u squared plus 4u plus 4. And we can factor this. This is going to be u plus 2 squared, so u equals -2. So tan x equals -2, and if we check